Good morning, ladies and gentlemen, or good afternoon, or good evening. In this video, we're going to start section 1-6, that is taking a function and transforming it, moving its graph around. The objectives for this section. We'll recognize graphs of the common functions, and then we'll use vertical shifts to move the graphs up and down. We'll use horizontal shifts to move them left and right. We will reflect those graphs either across the X or the Y axis. I think that will be covered in this video, and then there'll be a day 2 video to cover vertical shrinking and stretching of a graph, horizontal shrinking and stretching of a graph, and functions involving a sequence of transformations. If there's more than one, there is a specific order that they have to be done in. So here's algebra's common graphs. F of x equals c, or maybe you've seen a function like y equals 3. That would just be a horizontal line. Domain is all real numbers, negative to positive infinity, and the range is only that single number that we cross the y-axis at. It's constant. It's neither increasing nor decreasing, and it's an even function. Now, if we take the line y equals x, that's just the slope line of 1 going through the origin. Positively sloped, domain is all real, range is all real, it's increasing the entire time, and it's an odd function, x to the first. Remember here, if we throw in a constant, that will throw off our symmetry. The absolute value function of x. Remember, the absolute value bars make everything positive. So it's kind of like if we go back over here to this line graph, it's kind of like we took this part here that was negative under the x-axis and we bent it up here into the second quadrant. And now we got our absolute value graph. Domain is negative to positive infinity. The range on the y-axis is 0 to infinity. It never goes below. It's decreasing on the left and increasing on the right. It's an even function. Good old x squared, our parabola opening up. Domain is all reals, range is 0 to positive infinity. It's decreasing at first, and then it gets an interval from 0 to infinity where it increases, and it's the most basic of the even functions. Another common one in algebra, root of x. The root of 0 is 0, root of 1 is 1, the square root of 4 would be 2. So it's opening up, sort of like a parabola that broke in half and fell over. It's opening up here in the first quadrant. Notice the domain, 0 to infinity, only lives in the first quadrant. Range, 0 to infinity, only lives in the first quadrant. It's increasing across the entire domain, and it's neither even nor odd. Now here's our first, the most basic odd function, x to the third, x cubed. It's very similar to x squared, but here in the second quadrant, it doesn't open up. It's sort of like that got bent down here into the third quadrant. Because if we take the cube root of -1, that is -1. The cube root of -8 would be negative, or cube root of -8 would be -2. Domain, all reals, range, all reals. It's increasing all the way across, and it's an odd function. Now, if we sort of lay that graph down on its side, that is our third root of x. Third root of 1 is 1. The third root of 8 would be 2. And then we have this down here in the third quadrant also. Domain and range are all reals. It's increasing, and it is also an odd function. So these are the basic graphs, and what we can do then is shift these basic graphs up, down, left, right. We can reflect them over axes, and we can shrink and stretch them. The first and the easiest are the vertical shifts. Let's begin by looking at 3 graphs whose shapes are the same. The graph below shows this. The black graph in the middle is the standard quadratic x squared. So here's x squared, and that is the black inked graph here. It goes through the origin. It's our parabola opening up. Look at the blue graph now on top of it. The equation for this is the same x squared, but then we have a +2. The +2 shift us up vertically 2 units. And then they also have here this a different color graph, x squared -3. The +2 is changed to a -3. The original graph that went through the origin has now been shifted down 3 units. Let me show you something else from here. Let me make this graph a little bigger. Once you've got the basic graph, to get a few more points on the shifted graph, like let me do red ink here. If we're here at the black inked graph at the origin, from the initial spot on the y-axis, we go over 1 and up 1 unit. We also see that here where we cross it 2. We still go over 1, up 1 unit, we hit the graph again. Even down here on the sort of purplish graph, if I'm here at the y-intercept, I'll go over 1, up 1 unit. To get to the next one, we would have to go to back here on the black graph 2 comma 4. So to get to the next point from the original, we'd go over one more, up 3. And that would also be here on the blue graph. I could go over 1, up 3. And here on this sort of purple graph, over 1, up 3, I'm still on the parabola. So vertical shifts, let f be a function, c is some positive real number. The graph of y equals f of x plus c is the graph of y equals f of x shifted c units vertically upward. So if we're adding a constant, it's a shift up. If that is minus a constant, it's a shift down. So here's a little example we can try. Use the graph of the absolute of x to graph the absolute of x minus 4. Well, real quick, let's just recreate the absolute of x graph. Absolute of 0 is 0, absolute of 1 is 1, 2 is 2, 3 is 3, so we're going to be going up this way. And then the absolute of negative 1 is 1. The absolute value of negative 5 is 5. So there's a couple points if we connect those graphs. There's our basic absolute value of x graph. Now notice here the negative 4, the minus 4 is outside the absolute value bar, so it is a shift up or down. So this dot, let me switch to red ink, that was at the origin have been shifted down 4 units. And now since this graph, it's a straight line going up to the right of a slope 1, we can do that here. Just a few more spots, going diagonally through the graph paper grid. We can see that close enough. And then here on this arm of it, we're just going up and to the left. The slope here would be negative 1. We're still going diagonally through the graph paper grid. And let's make sure we hit negative 4 here, and we should have made sure we hit positive 4 there. Okay, because these points that were out here at 4 also got shifted down 4 units, so those points are now intercepting on the x-axis. Up next would be a horizontal shift, left or right. So we return to the graph of x squared, the standard quadratic function. Down here in the graph below, the function f is in the middle in the black ink. By contrast, the vertical shift situation, this time the graphs are to the left and to the right of the graph of the original function. Look at the blue graph on the right. The equation for this is, now notice, this function was x squared. Now a horizontal shift is going to be in there with the x value. So for this one, we have x minus 3. Quantity squared. Now here, this is sort of counterintuitive. If I go back to this, positive is a shift up. That makes sense. Negative is a shift down. For here, it's kind of backwards thinking. When I see this minus, I might first think I'm going to head to the left because that's where the negative numbers are in the number line. The negative numbers are to the left of the origin. But here it's sort of backwards. That a minus here is a shift to the right. So where the original graph hit here at the origin, we are now going to be hitting the x-axis at positive 3. From there, the rest of the graph will be the same. From the origin on the black graph, we could go over 1, up 1. Same thing here on the blue one, over 1, up 1, we'll hit a point. On the black ink graph, again, we'd go over 1 and then up 3 to hit our next point. We could do it here, go over 1, up 3. Just to get a couple more points to make our graph look extra nice. So in here again, a minus 3 is a shift to the right. Here in the sort of purple graph, we have x plus 2 quantity squared. So that plus is going to be a shift to the left. So if we come back here to the graph where we did hit at the origin, that's now here at negative 2. And for a couple more points, I'm going to go over 1, up 1, and then over 1 and up 3 more on our parabola graph. So there's our x plus 2 quantity squared. Let me just drive this home. If this was x squared plus 2, this would be a shift up. If we are adding or subtracting to the x before we square it inside these parentheses, that is our shift left or right. So a horizontal shift, f is a function, c is a positive real number. The graph, I don't want to update, get out of there. Y equals f of x plus c is our same original graph but shifted to the left. So the plus in there is a shift to the left. If it is f of x minus c, that minus is a shift to the right. Ooh, I see a great question down here. Using my intuition, it seems that f of x plus c should shift it to the right, and f of x minus c should shift it to the left, is my intuition on target when it comes to these horizontal shifts. And then the book says, no. On a number line, if x represents the number and c is a positive, then x plus c lies to the right of that, and x minus c lies to the left. This orientation does not apply to horizontal shifts. F of x plus c causes c units to the left, f of x minus c, c units to the right. Okay. Example 2. We're going to use the basic root of x graph to come up with the shift, the root of x plus 5. So let's just do the root of x graph here on the left. The root of 0 is 0, the root of 1 is 1, the square root of 4 is 2. So the graph is going to look like this, opening up to the right. Now we go from the root of x to the root of the quantity x plus 5. So that plus 5 is a shift to the left. So this dot that was at the origin is now going to be here at -5. And to give myself a couple more points, like from here back on the graph on the left, we can go up 1 unit and over to hit the next dot. So I'm going to go up 1 and over. Here's a dot. And from there, I'm going to go up 1 and over 3 more. So up 1 over 3 more. So that means my y-intercept here is just going to be a little bit over 2. Oops. There we go. So that plus 5, again, was a shift to the left 5 units. And that shifted all the points over. So combining a horizontal and a vertical shift. Now, I think I said earlier in the video that there is an order to doing the shifts. There's a little acronym. I think it's high school RV. The order to do stretches, shrinks, and these reflections and stuff. First, you want to do any horizontal. Horizontal left or right, and then you want to do stretches and shrinks next if there's any of those. And then the third one, R for reflections, and finally V for vertical, up and down. We haven't done the ones in the middle, obviously, so what we want to do, just to stay in this pattern, we'll do any horizontal shifts first, left or right, and then we'll do vertical shifts up and down. So let's see what we got here. So we've got x squared, and then we want to obtain x plus 1 quantity squared, and then minus 3. So let's just, look at this real quick. The minus 3, that is going to be a shift down of 3 units. And then the plus 1 in here, remember this is the one that's sort of counterintuitive. This is going to be a shift to the left 1 unit. So we're going to find our basic parabola graph. We'll do the horizontal one first. We'll move our graph to the left 1 unit, and then we'll move it down 3 units. So I got a few graphs here. I can get some of these out of the way. So here's x squared, our basic squared graph. The 0 squared is 0, 1 squared is 1, 2 squared is 4, and then we'll see those same on the negative side. -1 squared is 1, -2 squared is 4. So there's our parabola. Again, note here from the origin, if we go over 1, up 1, we get to the next point on the parabola, and from that point we can go over 1, up 3 to get to the next point. So again, first we want to do our horizontal shift. That'll be this one. X plus 1 quantity squared. So the part, let me go back to blue ink. The point that was at the origin is now here at -1. I can't draw, there it is. And from that point, I'm going to go left 1, up 1. Come on. And to the right 1 and up 1. So there I will be crossing the y-axis at 1 now. And from each of those points here, I'm going to go left 1, up 3. And here I'm going to go right 1 and up 3. Just to get a couple more points on my new graph. Okay, I'm going to erase this one, put our final graph. Oops. Let me see if I can bring that to the front. There it is. So here on the right in blue, we have our x plus 1 quantity squared graph. Now we're going to do the x plus 1 quantity squared and the -3. So this point here, the vertex of this parabola at -1 is now going to drop down to -3. And from here, I can just find a few more points. I'm going to go left one and up one. Come on, right one and up one. So now my new y-intercept is -2. And now from this point, I'm going to go over one, up 3 more. So I can see here, I'm not sure my exact x-intercept, but I can see it's somewhere between 0 and 1. And then from this point, I'm going to go over 1, up 3. For this point on the parabola, there we go. So we shifted left 1 and down 3. Checkpoint, some to try on your own. Looks like the first one is up, down. The next one is left or right. So pause the video, try these out, and then fire it back up. See if you got them right. Okay, the first one, absolute of x. Remember that goes through the origin. And looks like this. Let me make sure my points are pretty good. Here's 5, 5. Here's -5, 5. Close enough. So there's our absolute value of x graph. And now the +3 that is outside the absolute bars is going to move us up 3 units. So we're going to go up 3 and then again go diagonally through the graph paper grid to make our V-shaped graph. And then for checkpoint 2, the square root of x, the root of 0 is 0, the root of 1 is 1, the square root of 4 is 2. And if we went just out here off the graph paper to 9, we could go up to 3. So there's some points on our square root graph. And now this is the root of x minus 4. So the -4 is under the radical with the x, and that's a minus. So that's going to shift us to the right. Our point is no longer at the origin. It is now here on the x-axis at +4. Why can't this draw a good dot? Come on, there we go. And back over here to this one, remember we're going to go up 1 over 1, and then we can go up 1 over 3. So up 1 over 1 will put us here, and then up 1 over 3 more. That takes us to the end of the graph paper. And there's our shifted graph. Ooh, another one. Okay, double whammy here. Couple. We've got root of x will be our basic graph, and then the root of x minus 1, and then we'll shift that down too. So again, pause the video and try the problems. There we go. 1, 1. This thing is giving me so much trouble with dots. The square root of 4 is 2. Come on. Ooh. Hey, that works. Okay. And now from the root of x, we want to do our horizontal shift first, left to right. So that -1 means we're going to move over 1 unit. So now we're going to hit here on the +1 on the x-axis. And from that point, we can go up 1 over 1, and then up 1 over 3 more, just to get a couple more dots on the graph. And now the second shift, we're going to move every point down 2 units. So here, where we were at 0, 1, that's now going to come down to 1, -2. And then from that point, I'm going to go up 1 over 1, and there's another dot, and now up 1 and over 3 more. So here we've got our x-intercept right there on +5. So, we can even check our work. If we put a 5 in that function, a 0 should pop out. So if we put a 5 under the radical with that 1, 5 minus 1 is 2, or excuse me, 5 minus 1 is 4, and the square root of 4 is 2, and then minus the other 2 does take us to 0, and that's what we would expect graphically. We're hitting the x-axis. Now we can reflect about the x or the y, and sort of just to do them both in one shot here. Here around the x-axis, if I have my function y equals f of x, it's down here in the black ink. I'm going to hit over it in red. All our y values are positive. Y is positive, f of x is positive. So if I put a negative out here and I negate all of those answers, it means all these values that were up here on the positive y-axis are going to be shifted, and now they're going to be down here on the negative y-axis. So what that did is took the graph, and I wonder, did I do all this in one shot? Here in red, it just flipped it over the x-axis, and now it's living down underneath the x-axis because we made all the positive y values up here where the parabola used to be negative. So that shifted the parabola underneath the x-axis. To compare that to, if I were to put the x in there with the x, y equals f of negative x, that is a shift over the y-axis. So if the negation goes outside the function, it's over x. If you put the negative in there with the x inside the function notation, that's a y-axis reflection. So let's see what we got here. In the top graph, we're going to do the cube root of x, and then we're going to change that to the negative cube root of x, and it's as simple as flipping all the dots over the x-axis. So let's do third root of x here on the top. Third root of 0 is 0. Third root of 1 is 1. The third root of 8 would be 2. So in the first quadrant, we look like this. And let me switch to blue ink for this other part. The cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. So the graph looks like this in the third quadrant. Now, because we put this negative outside the function, it's not under there with the x, we know this is a reflection about the x-axis. So here, this red part that I'm going to go over again here, that is going to be reflected over the x-axis. So from the origin, instead of going up 1 and over 1, we're going to go down 1 and over 1. And then this point that was here at 8, 2, 8, 2 is now going to be 8, negative 2. So that 8, 2 is now 8, negative 2. We have negated our y value. So that's been shifted over the x-axis. Over back here to the blue part, that is also going to be shifted over the x-axis. So all the parts that were under the x-axis are now going to come up above it. So this point that was at negative 1, is now at negative 1, positive 1. This point that was down here at negative 8, negative 2 is now at negative 8, positive 2. The y values have changed sign to the opposite. So everything was reflected over the x-axis. Now here we talked about this when I introduced the other one about the x. Here with the notational difference, again, what we just saw before was y equals the negative of f of x. That is an x-axis reflection. If I put that negative in there with the x, f of negative x, that is a y-axis reflection. So the book says the graph of y equals f of negative x is the graph of y equals f of x reflected over the y-axis. For each point xy that were on the graph of the original function, the point negative xy is on the graph of this new function that's been reflected. So let's see what we got here. Use the graph of root of x to graph the root of negative x. So root of x I'll do here in red ink. The root of 0 is 0, root of 1 is 1, root of 4 is 2. So it looks like this. Oops, not good enough. That's a little better. Now because, again, we can't take the square root of a negative, so if we're going to do this, we would have to put negative numbers in. If I put in a negative 4, a negative would change it positive. So again, if we're going to use the red graph to make our next graph, again, from the origin, we're going up 1 over 1, up 1 over 3. Now we're just going to change that, and it's going to be reflected across the y-axis over here into the second quadrant. So we're going to still have 0, 0, but now we're going to have negative 1, 1, and over to negative 4 and up to 2. So that's not good enough. That's a little better. So now instead of the graph opening up and to the right, it's opening up and to the left from the origin. It's been reflected over that y-axis. A couple more for you to try. The first one, the absolute of x to the negative of the absolute of x. And then here we got our third root of x to the third root of the negative of x. So pause the video and give those a try. All right, first one here, f equals the absolute of x. That's just, we're going to go from the origin up to the left, up to the right, something like that, our V-shaped graph. Now the negation outside, that's going to take all these what were positive y values and make them negative. So our graph is going to live under the x-axis. I'll switch to blue ink. We're still going to have 0, 0. Let me get a good point here. -5, or 5, -5. Just so my lines have a pretty decent slope. There we go. So we used to open our V shape was up, and now it's opening down. We have reflected over the x-axis. Now here we got a third root graph. Why did I have these so small? L. Third root of x. The third root of 0 is 0. Third root of 1 is 1. Third root of 8 is 2. So it looks something like that. And if we go negative, third root of -1 is -1. Third root of -8 is -2. So it looks something like this. Now remember, here we had our third root of x. Here is the third root of -x. So this is a flip over the y-axis. Again, just to recap, this one up here was a reflection over the x. So this is going to be a reflection over the y. So I'm just going to do this on the same graph paper grid here, but I'm just going to use black ink. So this red part here is going to be reflected over the y-axis. So we're going to sort of open this way to the left. So this is the reflected red part of the graph. And then this blue part down here in the third quadrant is going to be reflected over the y-axis into the fourth quadrant. So from the origin, we're going to come down here to 1, -1, and out over to 8, -2. So again, the one graph in red and blue is the original graph, and then it's been shifted over the y-axis. Here we shifted this over the y-axis. This red part came over here, and this blue part came over here for our reflected graph. And that's all she wrote for this. Your homework is on probably Microsoft Teams.